Okay, question 11. We have a situation where a particle is moving along a horizontal line and his acceleration is given by this. V is greater than -1, which is going to be important. And also it says at t equals 0, the particle is at a fixed origin 0 and has initial velocity v0. So this is what we call an initial condition. I'm going to write that here. Initial condition. Okay, and then show that this equals this. So essentially what he's asking you to do is solve this differential equation. That's kind of the first kind of tricky bit, is to recognize that he's asking you to solve a differential equation and that this is a differential equation. It's a differential equation because A is actually dv dt. Now hopefully you know that. dv dt is equal to -1 plus v. Now it's also a separable differential equation, so I can just separate this by kind of cross multiplying. So I can divide by all of this, or I could actually leave the negative there if I want. Let's do that. I'm going to say it's 1 over 1 plus v dv. So I'm leaving the dv here, and that is equal to -1 dt, because I'm leaving the -1 up here. I'm leaving the negative there, and I'm going to multiply across by this dt. I can then say the integral of this is equal to the integral of this. What's the integral of 1 over 1 plus v? Well, it's ln of 1 plus v. Now normally, guys, yeah, we put in the modulus sign, but because this is why I said v is greater than -1. Because v is greater than -1, well, I can put in the modulus sign here, 1 plus v. But because v is greater than -1, this is going to be 1 plus v is going to be positive anyway. So I'll be able to remove the modulus signs in a second. This equals, the integral of this is -t, and don't forget the plus c, because there's a lot of marks. Well, you need the plus c if you want to turn it into this. Okay, initial condition. At t equals 0, v is equal to v0. That's this initial condition. So I'm going to sub this in here to get c. So I'm going to have ln of, now I'm going to remove the modulus signs at this point. So I'm going to say ln of 1 plus v0. And again, I can remove them because v is greater than -0. You could write that here if you wanted to, but it's not actually required. So 1 plus v0 equals, this is 0. I'm going to write 0 or -0, whatever, it's going to disappear. 0 plus c. So this is equal to c. So now I can write ln of 1 plus v is equal to -t plus c, which is this, ln of 1 plus v0. Okay, I'm going to draw a straight line here so I can continue over this side. Okay, so we're getting there. I have this and I want it to look like this. Now we can look at this solution and realize, right, what are we trying to find? Well, we're trying to find v, not v0, we're trying to find v in terms of t and v0. And you can notice, guys, there's no natural logs in this solution here, so I need to get rid of the natural logs. And the only kind of way to do that is to join them together. So that's what I'm going to do now. I'm going to say ln of 1 plus v minus ln of 1 plus v0. So I'm subtracting this v0 from both sides. This is equal to -t. Joining them together using the second rule of logs, I can say this is equal to ln of 1 plus v over 1 plus v0. This is equal to -t. Then I want to get rid of this natural log. How do I do it? Well, remember ln is log base e, so I can say this equals e to the power of -t. 1 plus v over 1 plus v0 equals e to the -t. That's by definition, if you look at in your formula booklet, how to kind of move from an exponent to a log, that's what you do. You get the base of the log and you raise it to this power. Okay, now we're very nearly there. I just need to multiply across by this, so I can say 1 plus v. 1 plus v, hang on, let me write it over here. 1 plus v equals this times this, so it's 1 plus v0 times e to the minus t, which is this part, and then all I have to do is say v equals 1 plus v0 e to the minus t, and then I'm going to subtract this 1, and that's what he asked me to show. 6 marks, Q, E, T.